So let's continue our lesson on 4.6, complex numbers. In Objective 1, what we were doing is just simplifying square roots of negative numbers. Objective 2, we are plotting complex numbers in the complex plane, finding their absolute value. Finally, here in Objective 3, adding, subtracting, multiplying, and dividing complex numbers. And the adding, subtracting, super easy. Multiplying, a little bit tougher, just a wee bit, because we have to deal with powers of I. And then dividing complex numbers is going to be very similar to rationalizing the denominator with irrational numbers. So in the picture here, you might recognize this as the Mandelbrot set again, and it is. This is a certain coloring of the Mandelbrot set called a Buddhabrot, because if you turn it on its side, just turn your head like so, it kind of looks like the Buddha, with like some sort of glowing heart thingy. Yeah, so there you go. It also looks like a very organic molecule. It's very cool. So adding and subtracting complex numbers, extraordinarily easy. You just add up the real parts and the imaginary parts separately. It's just like combining like terms. So if you look at these two examples here, in general, I have two complex numbers. I add up the two real parts, which is A and C together, get something. And I add up the two imaginary parts, the BI and the DI, and get something. For subtraction, I just have to make sure that I distribute the negative sign through that. Okay? Just the same kind of thing as combining like terms. Terms. Yeah, that's right. That's on the internet now. Okay, so first exercise here. I mean 11. Anyway, adding and subtracting some complex numbers. And even though this first one has some parentheses, we can ignore them because there's a plus sign in between it. So let's just add up the real parts here. I got a 12 minus 8, which is 4. And then add up the imaginary parts, negative 11 i's plus 7 gives me minus 8i. That's it. That's all there is to it. Okay, on number 2, I have a subtraction sign, so I'm just going to distribute this through, so negative 24 plus 9i. Now my real parts, 15 and the negative 24 gives me negative 9. And negative 9 and positive 9i, they cancel out. So there it is, just negative 9. And finally, again, I have a negative sign here, so let's distribute that through. Negative 13 minus 4i. Combine all our like terms. 35 and 13 minus 13 is 22. And our imaginary parts, minus 3i. Womp. Okay, so give you a chance to practice some of these rather complex problems right here. Pause and work those out. So number 1 here, 3 plus 6i. On number 2, make sure you distribute your negative signs, so negative 5 plus 9i. And then number 3, finally, you got 2 negatives to distribute there, negative 10 minus 10i. Not too bad, right? Okay, so now let's move on to some multiplying. Whenever you get to multiply complex numbers, 2 things are usually involved: some distributive property, or maybe some foiling, and simplifying powers of I. So mostly what I'm talking about is I squared is equal to what? Negative 1. So you might have to use that a bit. Okay, so look at the problem here. 2i times 3 minus 5i. So I'm going to use the distributive property here. Multiply that through. 2i times 3 gives me the 6i. 2i times negative 5i gives me negative 10i squared. I'm going to simplify that, because the I squared is equal to negative 1. Negative 10 times negative 1 gives me a positive 10. And if you stop there, you're a little bit wrong. We want to be pretty picky about this. We want to always write the real part first, so that should be 10 plus 6i. So let me write this as a reminder here that this is not in standard form. And we want it in standard form, or it's not correct. So put the real part first. So let's try a couple here. First one, just doing some distributive property again. Distribute here, so negative 5i times 8, negative 40i. And then negative times negative, positive 45i squared. And I always deal with my I squared parts first, so I squared is negative 1, makes this negative 45. Do I leave it like that? Instead, I want to write the real part first, so negative 45 minus 40i. That should do it. Ooh, look at number 2. What do you think we're going to have to use on this? If you said a 4-letter F word, you were right, foil. So first, negative 32. Outside, negative times negative, positive 56i. Inside, positive 8i. And then my last ones, negative 14i squared. Again, I deal with my I squareds first. I squared is negative 1, but 14 is already negative, which makes that positive 14. Combine that up with my negative 32, and I get negative 18. Add up my imaginary parts. 14 makes that 64i. Here we go. So here's an opportunity, another one, to practice what you just learned. Go ahead and pause. And we're back. Yeah, answers. Okay, there we go. So the first one, distribute through 1 plus 9i in standard form. Remember, real part first, then the imaginary part. Doing some FOIL business up on number 2, 16 plus 2i. Okay, let's move on to the next exercise. Multiply and classify the product. In other words, what kind of number it is. Kind of number. There we go. 5i times negative 5i. 5 times 5 is going to make that negative 25. Of course, I times I squared. We know that to be negative 1 makes positive 25. That's a real number. Okay, number 2, 3 plus 6i times 3 minus 6i. I don't really have to do FOIL on this if I recognize this as the difference of 2 squares, right? That's just the first number squared, which is 9, minus the second number squared, which is 36i squared. So let's keep going, because I squared is negative 1, makes this positive 36. Add the 9 to it, 45, which is also a real number. Very interesting. Number 2 here, this is, you might recognize it from the type of stuff we were doing when we were doing irrational numbers. And this is another kind of conjugate. What happens when we multiply conjugates together? Well, it looks like we get real numbers back. And that's definitely going to be true. So, whenever we go to divide complex numbers, you're going to have to multiply by the complex conjugate. So complex conjugates look like this. A plus bi and a minus bi. Just like I saw in this previous slide here. 3 plus 6i and 3 minus 6i, right? They're the same, as in they have the same numbers, but they're opposite because one here is positive and one's negative. That's what that word conjugate means. And the product of any complex conjugates is always a real number. Very, very handy. So the way that this is going to go whenever I divide these things is very similar to rationalizing the denominator. I'm running out of room, so denominator. Similar to rationalizing the denominator. And when we rationalize the denominator, we always multiply the top and the bottom by the conjugate of the bottom. Do the same thing here. You're going to multiply the top and the bottom of this by the conjugate of the bottom. The bottom is 1 minus I, so its conjugate is 1 plus I. So multiply that on the top and the bottom. Remember, I get to do that because this was just a fancy 1. Fancy 1, right? It's like I'm not changing it, but it's going to look different. Okay, so across the top we're going to have to do some foiling, and on the bottom I'm going to get a real number because those are conjugates. So whenever I go to FOIL up top, 2 times 1 gives me my 2, 2 times I, 2I, 3I times 1, 3I, 3I times I, 3I squared. The reason why the bottom is 2 is because we have 1 times 1 is 1, negative I times I is negative I squared, and that is negative 1, so negative negative 1 makes it positive, blah. Alright, so simplifying up top, this is the same thing as negative 3, combine it up with the 2, and we have 5 i's, just like this. And if you leave it like this, again, technically, you're only part right. You have to separate those things out to put it in standard form, so just divide both parts by 2. Negative a half plus 5 halves I, where the negative a half is the real part, 5 halves is the imaginary part. Okay, so dividing complex numbers, we're going to multiply the top and the bottom by the conjugate of the bottom. Let's try it. So write this quotient in standard form. So we're going to do this by multiplying the top and the bottom by the conjugate of the bottom. Of the bottom. I've got really good handwriting, don't you think? 5 plus I. 5 plus I. So across the top it's just foiling. So 3 times 5, 15. 3 times I, 3I, plus 20I, and then finally 4I squared. And on the bottom, difference of 2 squares, it's going to be 5 squared, which is 25, minus I squared. I always like to do the bottom first because it's easier and it's faster. So this is just negative 1, so minus a negative 1 makes it plus 1, 26 on the bottom, easy enough. Deal with this squared I first, that's a negative 4, combine it with the 15's lem, and we have 23 i's. Is this right? Not yet. Separate them out. 26 plus 23 over 26. Did I say 36? I. Okay, one more. You try it yourself. By one more, I mean 2. So pause. Here's your answers. Okay, remember, whenever you are dividing with complex numbers, you're multiplying by a conjugate of the bottom and on the top and the bottom. So number 1, 5 halves minus 5 halves I. Make sure that you are splitting this thing up so it's technically in standard form. And then number 2, multiplying by the conjugate of the bottom, 5 minus 2I gets 5. 3 minus 2I gets 3 plus 2I on the top and the bottom. Breaking that up, 11 over 13 plus 16 over 13I. Alright, there is one more exercise. It involves Mandelbrot set, but I'm going to do that as a separate video. So come back and see it. It's a kind of a bonus video, we'll say. Alright? So this concludes our lesson on complex numbers, 4.6. Okay, see ya.